So welcome to the launch of our newest member of the QSense family, QSense Omni. Biolin Scientific has been working with QCMD technology for over 3 decades, and now we're thrilled to introduce you to a groundbreaking instrument that will change how you spend your days in the lab. Developing QSense Omni has been an exciting journey for our team, and we're proud to present it to you today. Omni is the result of our commitment to research, innovation, and excellence. We understand the challenges that scientists face working in QCMD field, both in industry and academia, and our goal was to create an instrument that would provide an unmatched level of accuracy, reliability, and ease of use. We have worked to design a product that will help you to perform your work more efficiently, to obtain high-quality data, and to ultimately achieve your research goals. Omni will help you to make new discoveries, to push the boundaries of science, and to unlock new opportunities that were previously out of reach. So we thank you for joining us today, and we hope that you will be as excited as we are about the possibilities that QSense Omni can bring to your work. So let's not wait any longer. It's time for the big reveal. So this is a close-up of the instrument. I would like to show you some more details. To start with, this is the power on button. It's not only the light that you see here, it's actually a status light that will indicate the status of your measurement. It consists of 2 parts. The one to the right here is the base unit. To the left, you have 2 measurement channels. That means that the setup you see now is a two-channel instrument, but it can also be up to 4 measurement channels in one instrument. So this is where the action takes place. So if we open up here, we get access to the chamber. And this is where we have both the sensor holder, holding the sensor, the heart of the technology, and on top here, we have the sample holder, holding up to 6 different sample containers. And I will show you where you have even more possibilities of adding sample to your measurement. This is all in a temperature control chamber, patent pending temperature control chamber. And I can show you, if we go to the side here, we have also a bottle compartment. And this is where you can have like buffers or large volumes of samples. And there is also one bottle to hold the cleaning liquid that can clean this instrument. So the bottles that you have here can be used in all of the measurement channels. And this can, of course, be opened up. Normally we would have bottles, but today we're celebrating, so we brought some champagne glass instead. But that's only for today. And I forgot to mention one thing on the front side, so let's go back. In the front here, you have connections for connecting an external chamber. And this enables the use of QSense already existing accessory modules that enables you to combine QCMD with, for instance, electrochemistry or humidity measurements or microscopy studies, for instance. So very flexible and future-proof instrument. But let's hear what one of our beta testers from BASF in Germany has to say.
Hello, my name is Peter Stengel and I work in the research lab at BASF. I have been working with the QCM method for over 10 years and have recently been able to test the Omni. For us, QCM technology is a leading method for the investigation of adsorption and desorption processes or deposition and detachment at the solid-liquid interface on a nanoscale. We use the QCM method to clarify structure properties, relationships, and as a screening method for the investigation of interactions of dissolved substances on surfaces. This will provide a fundamental understanding and develop new formulations for a wide range of applications across BASF's entire portfolio, from detergents to pesticides and electronic chemicals. My experience with the Omni shows a user-friendly and intuitive software. The order of input is based on the workflow. Substances on surfaces. This will provide a fundamental understanding and develop new formulations for a wide range of applications across BASF's entire portfolio, from detergents to pesticides and electronic chemicals. My experience with the Omni shows a user-friendly and intuitive software. The order of input is based on the workflow. As in all generations of QSense devices, the same sensor type can be used. It is possible to enable an almost user-independent installation of the sensor. This allows a better quality of the measurement. A well-thought-out structure of a direct injection combined with internal rinsing processes, small volumes, and short flow paths enables very precise measurements with faster kinetics than before. I was impressed by the long-term stability of the QSense devices and the high degree of automation. The Omni offers the best data quality so far and can be used very flexible for measurements. Complicated measurements with many different rinsing steps and different solvents can be easily implemented. The measuring program can even be changed during the measurement. The automatic quality check allows the user to check whether the device and sensor are ready for the measurement. User-specified values can be used, for example, to check the quality of self-made layers. So the feature helps to perform measurements with always the same quality, which is very helpful. The Omni enables more operating options, which also means more time for the training of new users. With the Omni, however, emphasis was placed on making it as easy as possible for the user. Congratulations, QSense, to the new Omni.
It's a pleasure to welcome you to this launch event today where we will introduce the new instrument QSense Omni, a new era in QCMD technology. Today is a significant milestone for us as a company when we introduce this new cutting-edge instrument to researchers in surface science. Our team of experts has worked dedicated for many years to develop this, and we're now very proud to launch it to the market. Biolin Scientific today offers premium instruments, and we are market leader in surface science instrument today. QSense Omni is the result of many years in research and development, where we try to face the challenges the scientists can see in the lab, both in academy and industrial labs. Today, you will learn more about the instrument and what you can achieve with the hardware and the software. We would like to take the opportunity to thank our customers and our partners across the world for the great job, but also for your commitment and the input you have given to this project. Thank you for joining us today. Please learn more about the instrument on our webpage or reach out to our team. Biolin Scientific has distributing partners across the world, and we have offices in Sweden, in Finland, and in China. Let's hear from our colleagues in China, based in Shanghai.
Hi everyone, I'm Peng, and I'm working as application scientist in Biolin Scientific China branch office. The first QSense QCMD was introduced to Chinese market 20 years ago. I'm so excited that QSense Omni, our fourth generation cutting-edge QCMD product, is released now. I'm quite sure that you will love it when you see it. Elegant appearance, user-friendly, highly automation, more channel options, and excellent result with the lowest noise. I think it meets all QCMD customers' needs in industrial and academic field, and it will explore more possibilities in the surface science, providing you with a smooth journey to trustworthy results. Trust me, trust the QSense Omni.
You will hear from our Finnish office later during the day. It's now time for our external speaker, Joshua Jackman. Joshua is American with a background in chemistry. He did a PhD at the Nanyang University in Singapore and followed by a postdoc at Stanford. Today, he's an associate professor at the Sungkyunkwan University in Korea, and he will present the history of QCMD.
Hello. Thank you very much for inviting me to give a talk at this very important and exciting event for the QSense Omni launch. My name is Josh Jackman, and I'm an associate professor in the School of Chemical Engineering at Sungkyunkwan University in Korea. And it's my pleasure today to introduce QCMD technology, a historical perspective, and emerging biotechnology applications. For several decades, QCM technology, quartz crystal microbalance technology, has been critical for characterizing the deposition of thin films in various applications like semiconductors, optoelectronic devices, OLED displays, and many more applications. And many of the early work, much of the early work in this field was actually done in the gas phase. But since pioneering work mainly at Chalmers University by Professor Bent Casimo's group and numerous international collaborators, QCM was really shifted to QCMD a few decades ago by enabling energy dissipation analysis, which really pushed the boundaries of what is possible with QCM technology, especially for soft matter in terms of studying macromolecules like polymers, biomaterials, and colloids. And this really opened the door to a whole new range of measurement strategies, studying things related to biology, biotechnology, energy, medicine, just really opened the door to what is possible to study in liquid phases, such as water environments. Based on those technological breakthroughs that Biolin Scientific has really led in collaboration with Chalmers University and other leading institutions worldwide, QCMD technology has been really critical to studying surface phenomena, especially in the biological space. In our team, QCMD technology has really proved critical to studying various types of translational medicine applications, including developing new antiviral peptides that can actually therapeutically treat lethal Zika virus infections in mice. And actually, we discovered using this technology how to engineer the peptide so it works better, and also how we can develop a form of the peptide that can penetrate the brain to actually treat virus infections directly in the brain. Other areas that we've seen really huge opportunities with QCMD technology include areas like antimicrobial detergent testing. Recently, there's been some regulatory concerns about Triton X100 detergent that is one of the key virus inactivation agents that has been used historically in biopharmaceutical manufacturing. Due to certain environmental and health concerns about metabolic byproducts of Triton X, there's actually been an urgent search worldwide for developing new replacement detergents. And we've seen huge potential for QCMD technology to actually study the mechanism of action of those candidates and actually really accelerate the discovery of new candidates far beyond what is possible with traditional biological assays in terms of ease, speed, and really mechanistic insight. Beyond human health and personal care applications, we've also seen huge potential for developing new types of antimicrobial mitigants for use in the agricultural field. So virus infections are one of the leading threats to the poultry and swine industries for livestock production. And we've really started shifting the focus of our QCMD research to also understand how we can develop new mitigant mixtures based on actually mixing different types of molecules together and understanding how they interact with lipid membranes, which is really, I think, critical to the QCMD technology, that interface between the liquid phase and lipid membranes, which QCMD enables, has really allowed us to push the boundary even in fields as diverse as agriculture. And more recently, one of the main areas that we've really seen huge potential for the future is also understanding how anti-cancer peptides work based on studying their interactions with flat membranes versus curved membranes using QCMD technology. And we're now really starting to gain a lot of insight into different classes of anti-cancer peptides using this QCMD strategy. And I think for the future of anti-cancer drug development and pharmaceutical drug development more broadly, these types of surface-sensitive technologies, especially QCMD, will play increasingly important roles. So previously in the world, most regulatory pathways focus on looking at the effect. How do we stop a virus? How do we stop cancer in traditional biological assays? But I think the future of medicine and biotechnology is really understanding how things work in terms of the mechanism. How can we engineer molecules to work even better? And I think QCMD is really playing a critical role to answer these questions. And I look forward to a lot of great work ahead of us from our team and our collaborators worldwide. So once again, I'd like to thank you for inviting me to give this talk. And I hope that you have a wonderful rest of the event today. Thank you very much.
Thank you, Josh, for your presentation. The QSense Omni launch is a major milestone for Biolin Scientific, and for the last 9 months we have been targeting the 16th of March, and the day is today. Biolin Scientific long-term mission is to simplify and accelerate progression in surface science research. And this is what this launch is all about, taking surface measurement to the next level. Today, Biolin, we have strong presence in the academy segment. Most of the world-leading institutes worldwide, they use our technology in the exploratory research field. The last years, we have got the first footprint in the industry segment. QSense Omni is an enabler which will increase our presence within several of application fields going forward, such as pharma, chemical, and electronic. We will also, with QSense Omni, increase the number of users of our technology. QSense is today mainly used at the R&D Center of Excellence. Given the ease of use and the high quality data output, We are expecting the technology to be used at the regional and local R&D departments in the future. Our technology will support and generate important and unique data, supporting future important innovative projects in many different application areas. Eva, you are the global portfolio manager for the QSense brand. The project has been ongoing for approximately 3 years, and your role has been and still is very much to secure the customer's request and the long-term need within QCMD. What are the unique benefits that our current but also future customer can expect with this launch?
Yeah. So let's start by saying that this is a giant leap forward for QSense and for the QCMD technology overall. And we know from talking to many of our customers that QSense and QCMD, it's often a very important, if not essential tool in their scientific and research and development work. Its ability to track interactions at surfaces on a nanoscale, providing real-time data where you can follow the full process, and also allowing to set up model conditions where you can change conditions and you can use sensor coatings and surfaces that are relevant for what you are studying. Those are really unique benefits of the technology. But we also know that the reliability and reproducibility of the results are very dependent on the QCMD specific experience, skills of the user. And this is really what QSense Omni will help us change. So when we started the development project, we had a very clear ambition. We wanted to make it easier to perform QCMD measurements while getting trustworthy and reproducible results, because being a sensitive method, it is also sensitive to any external variations during a measurement. So we have really used 3 decades of experience, skills, know-how from developing and offering QCMD solutions, and we've sort of built a lot of them into this instrument by adding various new features and function and smart automation to really remove sources of human error and unwanted variation from the measurement. So you can say in a way that this instrument is taking over responsibility for measurement quality. And I mean, we've done so, of course, for the benefit of all our current customer groups, potential customer groups and customers, but we have had a specific objective with the project, and that has been to enable a broader use of the QCMD technology in the industrial setting, where a lot of those benefits that we bring with the product are very important.
You know, as I mentioned, this project has been ongoing for 3+ years. And at Biolin Scientific, we have a very, very dedicated R&D team and application team behind this unit. But we also have a marketing that has worked in close collaboration with our customers, as well as appointed partners, to secure that we bring in the market knowledge into this project. And I am so proud of all the stakeholders that has been participating during this journey.
And just to interrupt you there, I also want to take the opportunity to thank the QSense Advisory Board, specifically also other customers that have been helping us and supporting us along this journey, and in particular the beta testers, Franziska Tauber and Peter Stengel, and their manager, Matthias Kellermeier at BASF. It's been super valuable to have your insights and feedback for the product development. So thank you for that.
So next step, Eva.
Yes.
Next step is that now we are actually making this unit available for our global partners all over the world, with the aim to offering this unique product to our current and future customers in many different application areas going forward.
So welcome back to us here at Laborama. Let me present features of QSense Omni and the resulting benefits for the customers. And as we might have mentioned by now, QSense Omni opens up for a new era for QCMD. And when we started thinking about this new product to develop, we really did our homework. So we invested a lot of time in finding out what's most important for our customers when it comes to their QCMD instrument. Well, on top of that list was ease of use and great data quality. And then we developed QSense Omni. So now we have this instrument that has leading signal processing and direct injection fluidics that gives sharper and more concise data that is easier to interpret. Also, we really thought that it would be key to try to transfer the knowledge of our in-house experts to the software and to the hardware of this instrument. So now we have this intuitive design of the software that guides you through the whole process of running a measurement. Together with automation in the instrument, we now have a great start for successful and reproducible measurements. This means ease of use for the user. Also, we took the chance to make this very flexible and future-proof. So we now have smart functions and upgrade offers that lets you vary your experimental setup and add on capabilities. So one thing to start with is that it's built in a modular way. As you can see here, you can start with one channel measurement, one channel instrument to start with, and then you can upgrade to 2, 3, and 4. Or if you want, you can even start with a 4-channel instrument, of course. I would also like to emphasize that this is completely integrated. So this is the instrument that you need. No external pumps, no external anything really. And it has quite a small footprint. And I mentioned these channels that you can upgrade with. These are all independent, meaning that you can run with different samples, different scripts, different flow rates. But also all channels has their own electronics to process signal. And this means that each channel can collect data independently from the other channels. And here I have selected 5 features to highlight here today. And these are improved signal processing, fast and precise liquid exchange, sensor and sensor holder mounting, smooth journey to trustworthy data, and optimized measurement conditions. So let's go through these to see what they mean. So the first one, improved signal processing. One of the positive things with the refined signal processing that I mentioned is that high viscosity samples can now be measured while maintaining all of the harmonics. And in this graph, for instance, a sample with viscosity just above 50 centipoise has been measured with all the harmonics still there. And that is great news. Why is that great news? Because this enables better quantitative evaluation of data. The more harmonics you can record, the better chances of meaningful modeling results. And feature number 2, that is fast and precise liquid exchange, direct injection. We have also refined the liquid handling and liquid exchange over the sensor so that it's now very fast and precise with minimal unwanted diffusion. And we have something that we call direct injection, which is exactly what it says. It's a very direct way of ejecting the sample over the sensor. This means that you now get a truer representation of the interaction under study and a better view of what you're measuring. And this way, it's also easier to detect fast processes, of course. So if we look at the data curve here in this plot, where we go from water to sucrose, back to water, back to sucrose, and so on, we can see that this is very fast liquid exchange by looking at the steep slope. Also, you can see that it's very reproducible. You see the same value of the slope in each step. So reproducibility is also great. And how can we then achieve this fast and precise liquid exchange? Let's take a look at how the instrument is constructed. We have the sensor holder at the bottom. On top there is a sample holder with the samples on top. And the sample holder contains also this sample selection valve that directs the flow from the right position to the right position. And this flow is all driven by the syringe pump in the channel. And the flow of liquids from the bottles is also controlled by this syringe pump. And the construction of a sample selection valve and the flow channels is what results in the great liquid exchange over the sensor. And the key here is to reduce the risk of unwanted diffusion between samples and to get this plug flow of the sample instead of a liquid with a concentration gradient of the previous solution. So now when we've seen this construction, we can take a closer look at the technical solution. And what we will show here, for now, we've zoomed in on the flow that is just above the sensor. And this flow channel that goes to the left leads the liquid very close to, but away from the sensor. And the flow channel that goes down leads the flow over the sensor. So let's say that we have the system filled with water to start with. That's the liquid in blue. And that we want to switch to run a sample on top of the sensor. Then one might think that the sample comes as a plug in the flow channel, but that's not the case. So let's see if we can take a look here. We can see that there is a mix of water and sample for quite some time, up to a certain point where we actually have 100% of the sample. But when we guide the sample over the sensor then, we decide when to do that. We remove some of the first gradient, so to speak, and then when we have pure sample, we let it go down to the sensor volume. And this way, we get as close as possible to a plug flow. So with this refined sample handling, we get a very fast and precise liquid exchange. I might have convinced you already, but to make this even clearer, I can show you this data as well. Here we have two graphs, or one graph showing two curves, showing the liquid exchange of Omni in yellow and a conventional tubing-based system in magenta. And exchanging all liquid over the sensor is 5 times faster in Omni than the other one. And that brings greater data to the user. Feature number 3 then, correct and repeatable sensor and sensor holder mounting. QSense Omni offers a refined way of mounting the sensor and the sensor holder to reduce the frequency variation that we've seen with the other instruments upon remounting of the sensor. And the variation in QSense Omni is just 4% of that in one of the completely manual instruments. And why is this variation important to reduce? Well, if you want to be able to measure ex-situ-coated sensors, for instance, then this is absolute key. But how can this be achieved then? The first technical solution is the new sensor mounting guide that you can see in the middle of this illustration. This helps you to mount the sensor in a correct way so that it's perfectly centered, it's user independent, and it gives you reproducible mounting. The other technical solution that enables this is the automated and controlled locking that we have introduced in the instrument. And locking means that the instrument now uses the same and well-defined force to connect the sample holder and the sensor holder. And this is a process that used to be completely manual. So these both solutions helps to maintain the acoustic fingerprint of the sensor and result in a reproducible flow profile. And then feature number 5, smooth journey to trustworthy data. That might sound fancy, and perhaps it is. What we mean here is that the automation in QSense Omni gives improved reproducibility and minimum manual handling, something that both saves time and makes the measurement less user-independent. So we have automatic quality checks, automatic locking that I just mentioned, automatic sample handling, and automatic cleaning. And to exemplify this high reproducibility, we plotted a triplicate of frequency change over time here. And what we see is an adsorption of a small molecule, polyl-lysine, on top of the silica surface. And as you can see, it's quite reproducible. And the automatic cleaning that I mentioned also means that the instrument is ready for the next experiment in no time. Finally, feature number 5 is what we call optimized measurement conditions. And this one in particular is one of the things that I had in mind when I in the beginning mentioned that we've implemented a lot of our expertise knowledge into the instrument. We now have automatic quality checks to make sure that the instrument is ready to run, the sensor is ready, everything is stable, and that the conditions are then good enough to start the measurements, not to waste the precious time of the user. This happens automatically in the background, but all information is there for you to take part of. So a great foundation for successful measurements. But this is where I will wrap up this presentation. I know that my colleague Patricia will talk more about the greatly reduced noise levels of this instrument later on. So stay with us to hear more about that. But now let's check in with our Helsinki office to see how they're celebrating this launch day. Hi Marad, are you there?
Hi Jenny, and hello everyone. We are here with you from Finland's office. We are so excited and super proud, and I'm pretty sure the same for you. We have been waiting for so long. I'm
Definitely
sitting here next to Yini and Rayo, our guys from the R&D team. How do you feel, guys?
Great. It's finally we have done that job, and so in a point where we can launch the great unit.
Yeah, really excited. It has been quite a journey to come us thus far where we are right now.
But let's get a bit into the detail about your parts. What do you think was the most challenging in your part?
Well, for me, I think it's probably been the sensor holder, you know, to get the ease of use from the user point of view and incorporate that with the repeatable data on the mechanical aspect.
And what about you, Rayo?
I think the size is very challenging because it's very compact size and small size to get all those functionality in that limit space. Great.
About the features and capabilities, what do you think is the most unique about QSense Omni?
That fluidistics is great. So we have that special valve system to get that samples connected to sensor and get results very quickly, and it's great.
Great. One of the greatest features of QSense Omni is the upgradability and modularity. How do you think it benefits our users?
Well, you can start with small. You can start with the 1-channel unit, for example, and as your operations grow, you can go for 2 channels, 3 channels, 4 channels, and on top of that, you can introduce the satellite interface Omni with a lot of other modules that we have available. So you're not restricted on one ecosystem. So
that all sounds great, and I have to say congrats and well done on a great job. We get back to you, Jenny.
Thank you very much, guys, for putting a lot of effort into this project. I know that. But now is a great day. Here. Thanks. And now, thanks from Laborama over to Martin in the studio.
We will now learn more about the background and the development of the project. So welcome to the studio, Patricia. You're part of the application team, and you are one of the key application specialists that we have had in the project together with Fredrik Pettersson. You have been a vital part of the development of QSense Omni. And can you tell us a little bit about how it works?
Yes, thank you, Martin. Yeah, I thought about sharing a little bit about the vision behind the development of the software. So the idea was to reach the next maturity level of QCMD instruments. And for that, the software should be intuitive and easy to operate. It should be manageable to a wider user group. It should increase productivity and increase reproducibility. For intuitive and easy to operate software, we have used a modern UX design, and you also have the most used features already available in the first screen of the software. It also uses an everyday software features, for example, the drag and drop, which we use to make your measurement script. You also have scrollable screens. You can hide or show advanced options. To make the software manageable to a wider user group, the workflow of the software follows the same workflow when you're in the lab, preparing for a QCMD experiment. So for example, you usually start preparing your sensor surfaces by cleaning or coating your sensor. In the same way, the first screen, the software is the sensor screen, where you can add information about the sensor and even already start the temperature control. You follow up by starting preparing your samples for the experiment, and in the software we have the sample screen. Here you can add the information about the samples you're gonna use. And in the software we have the script screen, and here you can build up the script of your measurement. And then you continue for running your measurement. To increase productivity, it was implemented an automated experiment preparation. You can follow the progress of the background work if desired. We also have the option of automatic priming, where the sensor priming starts directly when the sensor has reached the correct conditions. There is no need for you to press a start button. You also have the option of live editing of liquid sequence, so you don't need to wait until your measurement is finished to try a different liquid sequence if desired. To increase reproducibility, we have implemented an automated quality checks. The quality checks has default stability criteria, which you can change if desired. You can also at the confirm screen check more details of the status if you want. And the main thing with the quality checks is that you will always start your measurements at the correct conditions. So now I would also like to show some data acquired with QSense Omni. And the first data I want to show is the multi-layer build-up. Here you can see positive and negative polymer interchanging and building up many layers, up to 8. And what I want to highlight here is the well-defined layers throughout the whole experiment. And this is due to the excellent liquid handling in QSense Omni. Now I also want to take a closer look at the first 2 layers. And I will first show data acquired with the analyzer instrument. And here I'm showing with more details. You can see all overtones over time for frequency and dissipation. And what I want to highlight here is the noise levels. So here's the data acquired with QSense Omni. With Omni, we have reached the lower noise levels than any other QSense instrument. And with lower noise, it's much easier to interpret your data. You can also get better modeling results. Besides that, of course, you can detect smaller signals as well. The next data I want to show is a protein adsorption onto silicon oxide pre-coated with polymer, followed by enzymatic reaction. Here you see 3 curves, and these curves show the 3rd resonance over time. And these are triplicates done at 37 degrees with a multi-channel Omni, and they were done simultaneously. What I want to highlight here is the consistency in the results. The high reproducibility in Omni is due to the less human effect when preparing and starting a measurement, together with the automated liquid handling, and the individual measurement channels for each sensor, due to the modular design of the instrument. The last data I want to show is an antibody assay buildup. This data was collected by Eric. It has many additions. It's a complex liquid sequence. Eric has done this experiment several times with other instruments, but this data he acquired when using Omni for the first time. So due to the intuitivity of the software, together with the less human factor when setting up experiment, and Omni's excellent liquid handling and automated liquid handling, together with the signal processing, Eric could get a high quality data already in the first try. So just to sum up, with the intuitive software together with the reduced human factor when starting up your experiment, and with the improvements in the QSense, such as with the direct injection for the liquid handling and the improved signal processing, it's easy to get high quality data with QSense Omni.
So let's move over to Kenneth Olesson. Kenneth, you are heading up the application team based in Gothenburg. You have long experience of QSense and the QCMD technology. As I understood it, Omni has the ability to produce fantastic data, but with significantly lower noise. Why is that so important?
Yes, so noise is something generally unwanted. So right now we're having this discussion in a very low noise room, so I can easily hear what you're saying. But if the noise were very high, it would be hard to hear you actually. And this would be the same for an instrument. So in an instrument you want really low noise to be able to detect really low signals.
Great, Kenneth. So besides being a compact and integrated system with a slick and outstanding design, what would you say make QSense Omni to a great instrument?
Simple question to answer. So Omni is extremely easy to use. I mean, I think that is the most prominent thing with Omni. It's easy to use and it does produce very good data.
So if we move back to software, the QSoft Omni, you have used it now for a while. What is your experience of it as a software?
Comparing to our own software, the Omni software is very easy to use, and you will have that visual guidance within the software in the QSoft Omni. And I think you can use the QSoft Omni within a couple of minutes without even opening the manual.
Thank you so much for your time, Kenneth. Our next speaker today is one of, if not the one, founder of QSense Omni. Here is today Peter Svensson, that is the R&D director at Biolin Scientific and has a long experience in QSense and the QCMD technology. Peter, you have been part of the project from the beginning. Can you tell us a little bit about the project, how it was developed, and also what goal we would like to achieve with the instrument?
Yes. So looking at the history, we have been pretty successful with the E-series instrument that was launched more than 15 years ago. It was the Explorer and Analyzer, and now we have an ambition to create the next generation of QCMD instruments. And we've had a lot of discussion about what areas to improve, and I would say that the most important then is to improve the ease of use of the instrument. And we also have identified a need for better repeatability. This is a very sensitive technology, and it's very important that you set up the experiment and do that in a correct way, so you get the same result always. And while doing this, of course, we have an ambition to get better data quality. That's the core of what the instrument will provide, of course, the data. Taking this opportunity also, we would like to make a new design that looks really nice, and not to least to mention that the footprint should be pretty small as well, because the space in the lab is precious. So here is this 4-channel setup of Omni that with a pretty neat design, I would say, and looks really nice if you ask me.
Thanks, Peter. I mean, the team has developed a fantastic instrument with great usability and design. Can you tell us a little bit how the ideas came to life and what was the challenge?
Yeah, I mean, looking at the prerequisites, as I started about ease of use and repeatability, how do you turn that into a technical solution? And what we have done is first thing which will make life easier for users is automation. To make a fully automated system where you could actually get data with as little human interactions as possible. You may think that human interaction is good, but that actually causes a lot of that's a source of error. So we would like to remove all this individual behavior in a way working with the instruments. And that goes very much then with the hardware, but also the software. The software is based on making scripts. So you make a certain script of an experiment, and that will bring the data from a predefined script. And that if you do that all the time, several times you will get the same result. And so that's one of the key things, automation, which is a part of the software, but also, of course, then the hardware, where we have a fully automated liquid management system, which I will show you a little bit about this. So what we got here, if you open one of the flow channels, we have, in this case, 4 different measurement channels, and here is the core of the liquid management. So what we got here is a piece of device where you add standard syringes where you can put the samples. So we have a place for 6 different lids, samples here, and then inside this little guy there is a valve. So what we do then is that we are operating this valve from this instrument, and then we can get the full liquid exchange managed in this small unit. So the flow path from the sample to the sensor is very, very small and short, which means that we got a full control of the liquid exchange. And there is a feature in this guy called direct injection, where we manage the liquid in a good way. So we had a really fast liquid exchange, which is one of the core things to get a good data from the instrument. So this is one of the key things. And second, we have also this guy where you mount the sensor. We refer to this as a sensor holder, and we have a lid where you will open this and put the sensor in this. And in order to get this in a very good and repeatable position, we have a specific tool that is used then to locate the sensor in the correct position. We put that on the lid and we put it into the instrument, and then when we operate the instrument, before we start the experiment, we are clamping this together with full repeatability, because that will be the same every time. The user will not interact in that. So that's That's the one of the things with liquid management, miniaturized flow path, and direct injections, which will bring better data in the end and a very good liquid exchange. And this sensor clamping that I talked about, then that will actually bring repeatability and performance as well, because the sensor will be mounted in exactly the same position every time, and that will bring repeatability and better data. One other thing which you don't see here, but inside this guy, there is a new electronics, which has been a completely new design, and which has increased the signal to noise level quite a bit. So we got way better data out of the instrument using this new electronics. And what we can't see here on this screen, that is the software that I talked about, that not only adding automation, but it also adds another feature which is really, really important. And we have this sort of a pre-check. So before we start an experiment, there are a lot of tests that are done automatically to guide the user. And if there is a problem with the something in the beginning, we can see that the data isn't what it's supposed to be before we start the experiment. We will wait until the instrument has stabilized and that has been okay. And if we don't reach that, we will actually not start the experiment. So that will also ensure that we get good data and not get a bad result. So that's pretty much, and I think we have been pretty successful in looking at the prerequisites and the goals from the beginning. So I'm really proud of presenting this QSense Omni in this version as a 4-channel instrument.
Thank you, Peter. It's now time to end our live streaming here today. I would like to thank everyone in the studio and everyone at the conference at Laborama. And of course, also a big thank you to our customers and the partners around the world. Thank you for joining us today.
Biolin Scientific are the pioneers of QCMD and provides world-leading premium solutions for nanoscale tracking of interactions at surfaces and interfaces. With over 20 years of experience and with more than 1,000 installed instruments in academic and industrial labs worldwide, we have learned a lot about our customers and their needs. QSense Omni is our new cutting-edge QCMD instrument that gives you sharper results and a smoother journey in the lab. With bold design and smart functions, QSense Omni is tailor-made for scientific progress and future innovation. It enables you to unfold unique insights quicker and base your decisions on more reliable results from highly controlled measurements. The smart guiding tool makes it easier to mount the sensor in the right position. Together with the automated and controlled clamping of the sensor, this prevents experimental failure, unwanted variations, and maintains the acoustic fingerprint of the sensor. The unique measuring chamber provides a stable environment with controlled conditions for reproducible results. The clever automation features minimizes hands-on time and unwanted variations. By upgrading to more channels or adding QSense Orbit for alternative experimental setups and complementary measurements, you can easily go beyond entry capabilities and grow with your research. This stable environment, background quality controlled setup, and automated procedures all work together to ensure successful measurement results free of unwanted variations, providing you with a smooth journey to trustworthy results.